Okay, so this is gonna be a pretty tricky differentiation from first principles question. It's asking us to differentiate 1 over x cubed to minus 3 over x to the power of 4. So let's start off by writing what f of x is. It's given in the question, but we will write it anyway to make it easier. So f of x is 1 over x cubed. Now before I do anything else, I'm going to write the equation of the first principles. So it's f of x plus h minus f of x all over h. Okay, so now I found out what f of x is. I'm going to find out what f of x plus h is. To do that, I'll just write f of x plus h. And this is just the same as saying 1 over x plus h all cubed. So what I'm doing right here is I'm turning just the x into an x plus h and putting the power outside the bracket. So I have the two main components of this question, so now I can sub everything in to the main differentiation equation. So I'll get f of x plus h, which is just that. So 1 over x plus h cubed. And then I'll do minus f of x, which is 1 over x cubed. And that's going to be all over h. So now, this is the first step. And remember, in each stage of your working out, you want to write lim. So limit as h tends to 0. Because at the end of this, your final h values will be turned into 0 and you'll be left with the differentiated form of what you're looking for. Okay, so now the easiest thing to do here is to make the denominators the same. This will work for any question like this, which is 1 over x squared, but we're doing 1 over x cubed here, so it's going to work for all of this, all of the same 1 over x values. Okay, so I'm gonna now solve these by making the denominators the same. So I'll do x cubed, I'm multiplying the top left by x cubed and the bottom as well. For now I'll just keep it in this form, so I'll do x cubed x plus h all cubed. Okay, now I'll do the same thing on the right. I'll just do, because this and this is just, it's going to be the same, so I'll do minus x plus h cubed. There you go. So that's the same thing now. And don't forget all over h. Now from here, we can subtract the numerators and then simplify this as much as we can for now. So what I would do is I would expand this top right. So I'll do this at the bottom left here. So x plus h, x plus h, and x plus h. This turns into x squared plus 2hx plus h squared for the first two brackets. Now I'll bring the last bracket down. And then this will just turn into x cubed plus x squared h. So I've done the first term, get rid of that, plus 2 x squared h plus 2h squared x. Done the second term, plus h squared x plus h cubed. Okay, so that's that done. We can now basically just replace this top right with whatever we got here. But let's collect like term first. So we got x cubed plus 3x squared h plus 3h squared x plus h cubed. So that's that done. Now you can get rid of all of this working out. And we can just basically now sub in whatever we got to the top right numerator. So let's get rid of this right here. So this is the same as x cubed plus 3x squared h plus 3h squared x plus h cubed. And now this is all multiplied by a negative sign basically. So you basically have x cubed minus x cubed, and then the rest would become minus 3x squared h minus 3h squared x and minus h cubed. So let's just finish solving this box that we have right here. So these two cancel out, and now you basically just have minus 3x squared h. So just to make it easier, we'll just put a bracket here so that you know it's multiplied by a negative. So 3x squared h minus 3h squared x minus h cubed, and then all over x cubed x plus h cubed, and all over h. Now here's the important part you have to remember for any question like this, because all of the numerator right now, so the numerator I'm talking about is this bit, is being divided by h. This is just the same as saying, let's get rid of this h actually. This is just the same as saying divide by h. All of this is divided by h, which is also the same as saying multiplied by 1 over h, using fraction rules. So if I were to multiply the top by 1 over h, I would basically just get rid of this 3, and this would become a 2, get rid of this squared, and this would become a h, and get rid of this h completely. Now I'd be left with minus 3x squared minus 3h x minus h squared all over x cubed x plus h squared. Alright, so looks a bit weird, but that's basically it. So this is our, when removing the h from the denominator, we get this. So now we basically can't do anything else, so we would now expand the denominator, because that's the last step before we turn h to 0, because now we actually can't do anything. So let's first expand the denominator at the bottom left. So you have x cubed, and now x plus h squared is this supposed to be x plus h squared? Wait. No, sorry, it's supposed to be a cubed. That right there was supposed to be a cubed. And now x plus h cubed is just the same as this, what we had before, right here. This box up here, so we can just use that. This will be the same again, once again, for any 1 over x values, because the numerator was multiplied by the denominator here. So let's continue with that. So we have x cubed multiplied by everything here. So x cubed multiplied by x cubed is x to the power of 6. X cubed multiplied by 3x squared h is just 3x to the power of 5 h. Here it's plus 3x to the power of 4 h. And the last one's plus h cubed x cubed. That's our denominator value. And now if we bring back the numerator over this, which is minus 3x squared minus 3hx minus h squared. So now we can proceed to turning h to 0, because this is our final fraction. But before I do that, remember to write lim h to 0, and always do this on the left hand side of your page over here. But this isn't a paper, so I'm just gonna really quick show you. So lim h to 0. Now if I make h 0, this will completely go, this will completely go, this will completely go, this will completely go, this will go, but the ones with just x will stay. Also remember on your paper to show that you've subbed in 0 and then get rid of it, but I don't have much space, so I'm not going to do that. So I'm left with minus 3x squared over x to the 6. Now dividing the top and bottom by x squared, I will get rid of the x squared from the top, get rid of that 6, and it will become a 4. So minus 3 over x to the power of 4, which is what we were trying to prove in the question.